So in this video, we're going to talk about section 2.11, and then we'll just kind of mention the important bits of 2.12. So starting with 2.11, it's on logical inference. So it gives us sort of an opportunity to think about what we know from different statements. So let's say I'm given the statement P implies Q. So it is 100% true that P implies Q. And then I want to know, is P true or is Q true? Right? I don't know. Just because I know that P implies Q doesn't give me any information about either the truth value of P or the truth value of Q. However, sometimes if I have a combination of statements, I can put those together to learn more. Right? So if I know P implies Q and I know P, then we can sort of like add these up. That's kind of the notation that I'm using here. It's kind of like a sum, but I'm not going to draw a plus or anything. I'm going to sort of think about what I can conclude. Well, if P always implies Q, so whenever P is true, I know that Q is true, and I know that P is true, then I can conclude that Q must be true. So right, if I have P implies Q and P, then I can use those together to deduce that Q is true. So that process is called logical inference. And we'll talk about some of these common forms of logical inference that we're going to do in this course. So I've listed 3 of the main forms of logical inference here. There's the one we just talked about, where we have P implies Q. So whenever P is true, Q is true. And I also know P, so therefore I can imply Q. So this has a special name, modus ponens. Potens? I don't even know how to pronounce it. I do not know these names. I have never learned them myself. I can't even spell it, as you can see. So I will never ask you them, but maybe you're interested in having these special names for these logical structures. All right, let's look at the next one. It says P implies Q, and we also know not Q. So what does that mean? So I know that Q is false. Q is false. That's what I know. So let's say if P was true, then because P implies Q, then Q must be true. But it's not true, it's false, so that would make us sad. So it can't be true that P is true, because then Q would have to be true, and it's not. So it must be true that P, is false. So if I know that P implies Q, and Q isn't true, it must be true that P is also not true, or that P is false. So that's called modus tollens. Again, you don't really need to know these names, but maybe you like them. And the last of our named statements is the following. If I know that either P or Q are true, and I know it's not P, well then it must be Q. And that's called elimination, right? We have this situation where one of 2 things must be true. It's either P or Q, and it's not P, therefore it has to be Q. So that's that elimination one. So you can kind of look at these 3 different things. We will certainly get used to using them. You probably already use them a lot in your life, especially this guy and this guy. But we'll get used to using them a lot in proofs. But if you have any questions about these, certainly we can discuss them together and let me know. All right, there's 3 more. These don't necessarily have names to them, but they're things that we're going to, again, use a lot. So let's say I know P is true, and I know Q is true. Well, then I know P and Q is true. Right? So that's not really that helpful, but we will actually end up doing this in proofs, right? Maybe I'm trying to show that the and is true, so I can show them each individually. If I know P and Q are both true, well, then I can deduce that P is true, because if they're both true, one must be true. And if I know that P is true, well, then I can be able to deduce that P or Q is true, because I only need at least one to be true. All right, so these are the sorts of little things we'll use in proofs without really thinking. Section 2.12 just sort of ties up this whole section from the book. this whole logic chapter from the book. So I've included basically the entire section here. This is just a screenshot from it. But I encourage you to go through and read through this, either pause the video and read it there if it's clear enough, or to go find it in that book. But it's just sort of tying everything up and saying, okay, so what are we actually doing with logic? So logic is going to allow us to really understand the meaning of these words. So things like and or, it's going to allow us to understand the meaning of an implication. And when we get into our proofs, we're going to have to really firmly understand exactly what those mean in a mathematical context in order to actually go about proving them. So we're not going to, do too many truth tables as part of our proofs. We're not going to always have things always written in symbols, but it's good to know the really strong underlining meanings of all of these symbols and all of these concepts in order to help us understand that proof. So again, if you want to go ahead and read through this section, it's only, half a page, so I encourage you to do that. But there's no more sort of mathematical content in here. It sort of just summarizes everything and ties it all up.